Hello everyone, it's Haresh here. Today we're going to be learning about a method what we call complete the square, or you can say completing the square. And the real reason why we use the method called complete the square is basically when we have a trinomial with 1, 2, and 3 terms, a trinomial, when we can't make factors for the trinomial, we use a method called completing the square. And really what we're doing is we're creating a perfect square on the left side of the equal sign so that we can take the square root of the perfect square and we can solve for the variable x. Whenever you create factors or whenever you're solving for the perfect square, you're always solving for the variable or you're solving for the unknown. In this case, we can't solve for x, so we have to use a method called completing the square. And completing a square will always work as long as you have a trinomial on the left side or the right side and it's set equal to 0. So let's see what would happen if we had a regular trinomial and we didn't have to solve for a perfect square. So let's use an example where we have x squared plus x minus 6 is equal to 0. So as you can see, this trinomial here, we can easily create factors out of this trinomial. So let's say, for example, x plus 3. And then we're going to multiply that by x minus 2. So in this case, we have a perfect trinomial where we can solve for two of the unknowns. So we set one side equal to 0. So x plus 3, we set it to equal to 0. And we solve for x. And we're going to minus 3 on both sides. And we're going to get is x is equal to negative 3 as one of our solutions. And then for our other solution, we're going to set x equal to 0. We're going to add 2 on both sides. And what we're going to get is x is equal to 2. So two of our solution is, one is x minus 3. The other one is x plus 2. So in this case, we don't have to use the method called completing the squared. So let's see what happens if we learn how to complete a square. And in order to do a complete square, we have to figure out what are we solving for. In this case, we're solving for x. And how do we have to think, how do we get x by itself? Well, the first thing we can do is remove all the constants. So in this trinomial, we want to remove all the constant. Now, how do you remove the constant? You want to do the inverse operation. So as you can see, you have a positive 6. But now what we're going to do is we're going to subtract 6. And whatever we do to one side, we're going to do it to the other side. So our new trinomial, or our new equation, is going to be x squared. I should just write that better. We're going to get x squared plus 10x. Remember, plus 6 minus 6 is basically 0. And then 0 minus 6 is negative 6. So this is our new equation. Now we're going to further simplify. But in this case, we can't create factors. What we're going to do is perfect square. We're going to create a perfect square. How do we create a perfect square? So the first thing we want to do is take the coefficient, right? The coefficient of the term that has a degree to 1. So this x has a degree to 1. This is the coefficient that we're going to take. And when we take that coefficient, right, so in this case it's 10, what we're going to do is we're going to divide this coefficient by 2. And then we're going to take the power of it to 2 as well. And you're going to see just in a second why we take the power of 2 and why we divide by 2. So when we divide by 2, right, our next solution is going to be 5. And we're going to take the square to that. And our final solution is going to be 25. Now 25 is a perfect number because 5 squared is 25. And the reason why we do that is so that we can complete the square. We want to create a perfect square. So now we're going to take this 25 and we're going to sub it back into our trinomial. So let's rewrite this equation where we're going to have x squared plus 10x. We're going to keep this 10x. Now we're going to sub in our 25. And remember, whatever we do to one side, we're going to do to the other side as well. So we're still going to keep the negative 6. And now we're going to add this 25 on the right side. So what is our new equation? Well, our new equation is going to be x squared plus 10x plus 25 is equal to 19. So this is our new equation. Now from here, we're going to create a perfect square. As you can see, x squared plus 10x plus 25, you can easily create a factor from that. So what is our factor going to be? Well, we're going to get our first solution is going to be x plus 5. And our second solution is going to be x plus 5 as well. But remember, this is not our final solution, right? This is not our final solution. We have to go on further. And this is set equal to 19. So now what are we going to do is we're going to solve for the x. The whole reason why we're doing this is to solve for x. So let's try it. Let's see what happens. So when we solve for x, what we're going to do is, since x plus 5 times x plus 5 is basically saying x squared, no? So this is basically saying x squared. And why is that true? Well, it's x plus 5 times x plus 5, so it's x squared. And this is set equal to 19. So let's learn how to solve for x. Well, what's the first thing we should do? Well, we should do the inverse operation. In this case, we're taking it to the power of 2. So x plus 5 is a quantity of squared. So we're taking it to the squared. Well, now what we're going to do is we're going to actually take the square root in order to do the inverse operation to get this x by itself. So we're going to take the square root of x plus 5 squared. And remember, whatever we do one side, right, we're going to do it to the other side as well. So we're going to take the square of 19. And remember, whenever you take the square of any number, it's either going to be plus or minus. It's either plus or minus. In this case, there's two solutions because we have a trinomial. So let's further simplify. Now, what's the next thing we can do? Since our square root, our squared symbols out, now we are going to have is x plus 5 is equal to plus or minus square root of 19. So what's the next thing we can do? Well, we can remove this 5. We can do the inverse operation by subtracting 5 to zero out this part. And then whatever we do to one side, we're going to do to the other side. So what is our new equation going to look like? Well, actually, by this time, we actually solve for x. So we're going to get is our first solution is going to be, so positive 5 minus 5, 0. Our first solution is going to be x is equal to negative square root 19 minus 5. Our second solution, or actually we can rewrite this better. We can write this as negative 5 minus root of 19. And our second solution is going to be x is equal to positive 5. Sorry, negative 5 plus square root of 19. So these are our two solutions. And we easily solve for x. And if we put this in a calculator, we would get our final answer. So remember, completing a square is only useful when we cannot create factors within a trinomial. So that's the reason why we use complete square. I hope you guys found this video useful. Definitely subscribe and have an amazing rest of your day.